This information looks fairly complicated, but let's start with a diagram. Just get a diagram down and then just put down whatever knowledge you have and it might come together. So we are told, first of all, that f-x is greater than 0. That means the function, the gradient is always positive. It's never going down like that. So I'm just going to sort of treat it kind of as a sort of exponential kind of thing. And then we're told that's at point P, the value of x is a. And remember, this function is y equals what, f of x. So a follow on from that is that this will be f of a. We have a tangent and normal to these curves. So this curve, so I'm just going to roughly put that down. There's the tangent. And the normal, remember, it is at right angles, so it's over here somewhere. And the tangent cuts the x-axis at A, capital A, the normal at capital B. And we are asked to find, or at least show, that the area of APB, that is this purple region here, is equal to this. So what we're going to need to do, right, is find the area of a triangle. We've got the height of the triangle, it's got f-a in it. Sorry, FA in it. We just need to find A and B, and then we'll have the base of the triangle. Here goes then. So first of all, the gradient of the tangent is going to be the same as the gradient of the function at P. That is what the tangent, that's a definition of the tangent. It has the same gradient as it touches the curve as the curve. So that is simply going to be f-a. Then the normal gradient is the negative reciprocal. So it's going to be minus 1 over f-a. We have a point that both go through, so we can use that and actually get the equations of the tangent and the normal in terms of A. So I'm going to use y minus y1 equals mx minus x1. That's typically what I always use in A level. So y minus f of A is equal to f dash a x minus a. At capital A, y is equal to 0. So x minus a will equal minus f of a over f dash a. All I've done is set y equal to 0 divided by f dash a, and then put the x minus a on the right hand side. So x is going to be minus f of a over f dash a plus a. I probably should have done it the other way around, so it's a minus that. But yep, that's going to be our answer. I could potentially, let's do it. So it's going to be a f dash a minus f of a. So I've written the a first and I put it over a common denominator. Okay, this looks a little bit neater. So that is actually the x value here. And then the normal y minus y1 equals m, but now the gradient is 1 over f dash a x minus a. So at B, remember when y is 0, so we're actually going to get f a, if I can times through by f dash a, and I can add minus, and then minuses will cancel, and that will equal x minus a. So x will equal a plus f of a, f dash a. And therefore we have the base of the triangle. It's going to be whatever we have, because the gradient is always positive, b is always going to be bigger than a. There's no way that you can, the normal is always going to be going in this direction, having a negative gradient. So we can work out this distance here, base the triangle, or maybe I'll just call it AB. So it's going to be this minus that value from above. And then the area of triangle APB will equal half base times height. Well, let's put the height in here, f of a. And now we need to put in all that stuff here. Now, final answer looks quite simplified. So let's we need a common denominator to start with. So let's get this f dash a as the common denominator. So it's going to be a f dash a plus f of a f dash a squared just realize it's not quite gonna fit on, so let me move it here, put a times in there. And then I'm going to be minusing a f dash a and plussing, because it's a double negative, f of a all over this common denominator. This is good news because I've got an a f dash a and I've got a minus a f dash a. And I can now see I've got a common factor of f of a, so I can, in my answer, it's always good to refer back to the answer. Remember, yeah, we've got this, so I can pull that out. And then in another bracket, I'm going to have f dash a squared. Okay, I've taken this one out, and then it's going to become plus 1. And that, I think, is exactly the same as the answer. So we are there. So that was part A of the question. For part B, we're told that f dash x is actually e to the 5x. So yeah, that's an exponential. Actually, it wouldn't go below here. It would look kind of similar, a bit like that. And the area is e to the 5a. And we're asked to find a. Okay. All right, got it. So f of x is equal to e to the 5x. That means f dash x equal to 5 e to the 5x. And then we're told, sorry, I've already forgotten what the area was. I want to make sure I don't make a mistake. E to the 5a. So e to the 5a equals a half. Now f of a is e to the 5a, so I need to square that. And then I've got 5 e to the 5a, which I am also squaring, plus 1 all over 5 e to the 5a. Now I can cancel out, because I'm dividing by e to the 5a and timesing by e to the 5a all squared. I can actually get rid of that square. And I can also cancel this one out with this one. So I'm left with a 1 here. So I can times through by 2 and times through by 5. I'm going to get 10 equals, I'm not going to rush this, 5e to the 5a all squared plus 1. So I can minus the 1, 9. Now when you have something like this, we square both. So we square the 5 and we square the e to the 5a. Now when I square that, I raise this to the power 2, which means you multiply the indices. So we're going to get e to the 10a equals 9 over 25. Going to take, well, the inverse operation is that 10a equals ln 9 over 25. And therefore a is equal to 1 over 10 ln 9 over 25. Does it say to leave it in any particular form? Find and simplify. Okay, technically this can be simplified because these are square numbers, so we could write it as ln 3 over 5 all squared. We could bring the 2 down, and therefore it's going to be 1/5 ln 3 over 5. That is the full final answer.